This looks like any suburban neighborhood built in the last 25 years, right? New streets lined with similar homes, all built at assembly line speeds by national home builders. And this neighborhood is that, partially. But this block of houses outside of Austin, Texas, is just the start of what will one day be a model of how to deploy sustainable living that's accessible and affordable.
Welcome here to Whisper Valley.
Axel, glad to be here.
Sure.
Looks like you guys are well underway.
Yes, we are. Phase 1 of 51 more phases to come. 7,700 house units on more than 2,000 acres.
So this isn't just a subdivision, you guys are building a city.
Yeah, it's a city, eventually for about 30,000 residents, yes. I mean, think about not only the houses, think about commercial, retail, school sites. We just opened our first community center with the geothermal heated pool.
Wow.
So there's a lot of things to come.
I mean, I'm a city dweller. I love having everything easily accessible and nearby. I don't have to drive anywhere. I mean, the fact that you guys are bringing that to the suburban life, really
Actually,
cool.
we call it suburban. It's suburban and urban. It's a mini city where you get all the amenities very close by, yes.
That's awesome. And what really drew me here is the renewable energy, the net zero aspect.
Very important. We call it zero energy capable. So every homeowner in Whisper Valley is empowered to have a very low or zero utility bill. The difference is we created an infrastructure who enables every house to reach that goal.
It's possible that each house could produce as much energy as it consumes.
That's correct. It's all about energy behavior, but yes, with the solar, with the geothermal, all the other technologies, a homeowner can have a zero utility bills.
Awesome. Well, can I see how you guys are doing it?
Yes, I'll show you one. So Ross, this is one of the first homes here, just finished a few weeks ago.
I mean, I'm looking at it. I mean, it looks like a standard house for a development like this, but obviously I see solar. I'm not used to seeing that.
Yes, so 18 panels, that's right, 5 kW, and that solar system, that kind of solar system is on every house here.
So 5 kW will handle your lighting, appliances. I mean, it gets hot here in Texas. Is it going to make much of a dent in your cooling load?
Good question. So if we would use a conventional air conditioner, we would need much more panels, but we do it differently, and I like to show you how.
Okay.
It's this way. So it's all about infrastructure. So as a developer, we are responsible for building roads, streets, water, sewer, electric services. In our case, we thought, what can we do as a developer to provide an energy efficient source for heating, cooling? We call that source geothermal loop field or Geogrid.
Okay, so what's a Geogrid?
It's very simple. The way this works is we have installed a central pumping station, an entire piping system for each neighborhood in our community, with a single main supply and return line that every house in that neighborhood is tied into.
And those pipes are installed long before the house is even built?
Absolutely correct. This is more cost effective to drill the entire neighborhood all at once, and eventually this entire street will be filled with houses. Each house has a recirculation loop and a pump to call for heating and cooling as it's needed.
I mean, that's the magic of geothermal. The outside temperature can go from over 100 degrees in the summer to below freezing in the winter. But what people don't realize is below our feet, we've got consistent temperature that we can tap into.
Exactly, very correct. And that happens under this green cover. Each house also has its own borehole that goes down about 360 feet, and it is connected to the central loop, which ensures that every building in this neighborhood gets the same level of heating and cooling. In the winter, when there's a demand for heat, the wells actually pull heat from deep below the ground and sends it into the house. And then in reverse, in the summertime, when there's a demand for cooling, the heat is pulled from the house and sent back down under the ground. So Ross, this is the heat pump. Very simple, it's all within the attic. We are here on the top of the house.
Yep.
You see those two pipes, supply and return. This is actually connected with the cover box outside in the backyard of the house. So we supply and we return hot water, we circulate and we take temperature out of the house or bring warmer temperature into the house in the winter.
Got it. So this is connected to the geofield.
Correct.
In the backyard.
Yes.
This is the circulating pump that's going to run and send flow it through.
Exactly. So you have a thermostat in each house. The thermostat kicks in. It actually starts the circulation pump. Yep. It creates that demand being connected with that loop field. Yep. And that is circulating water through the system so that we can extract temperatures or we can supply temperatures.
So this does the heating and cooling, but it also does the hot water.
Exactly. There are two more connections which will be connected when the family moves in.
Yep.
It's for hot water. Actually, we are taking waste heat out of each space and we dump it in the hot water tank.
That's great. And what I love to see also is that you've done some really nice job insulating the roof rafters.
Spray foam.
So all of your equipment is actually inside the conditioned envelope.
Exactly. That is a very critical point. The entire heat pump unit, the ductwork is within conditioned space. Actually, there is no outside unit at all. No noise pollution. The unit is protected from the environment. So the lifespan of a geothermal unit is about 25 years, so much longer than a conventional air conditioner.
Yeah, I love how there's nothing outside. It's nice.
Yeah. Ross, welcome to one of our model homes.
I mean, this is really nice. Granite countertops, some really nice appliances. I could get used to this.
So this house has 1,700 square feet, 3 bedroom, 2.5 bathrooms.
Okay, and then price range.
Yeah, so the low 200s to the high 300, maybe $400,000.
And this one?
And this one is exactly $300,000.
And then what's your median price?
In Austin, the median price is about $350,000.
So $50,000 below market rate.
Yes.
For this level of house, new construction.
Yes, and it includes all the energy efficiencies which we were talking about before.
That's really impressive.
Yeah, it is.
All right, so what I really want to know is how did you get that affordability? How do you get the price so low? Geothermal alone for a house like this could be $20,000 or $30,000.
It's all economy of scale. Installing that infrastructure upfront, purchasing with a scalable purchase power, all those products, and installing in a very efficient way. In all that context, we could reduce the price so that we keep energy efficient technology affordable for an average home buyer in America. We are applying that not only on the geothermal side, we are applying it for the solar and for a lot of other features of those homes. An example is our gigabyte fiber internet service, which is available in every house. Why is that possible? Because we provide a fiber connection using the same trenching which we use for the geothermal. So it's all about putting technologies together and scale it up so that a community like Whisper Valley provides all those services. If you really see it from an infrastructure standpoint, this is how you get the cost down so that it is affordable for everybody. If you do it on a house-by-house approach, you don't create scalability. If you do it community-wide, you really create smart cities all over the place. So I believe our concept here in our neighborhood is a great blueprint for other developers in this country so that you have better homes being built in America, community by community.
It's very exciting, Axel. I thank you for the tour, and I wish you all the best in the future phases.
Ross, I thank you for coming.
Pretty cool story. And I gotta admit, I've always been a fan of geothermal heating. It's sort of my favorite alternative energy source. It's only got one flaw, and it's the upfront cost. I mean, they can be huge and unknown.
So a typical house, you're right. I mean, it could be $15,000, $20,000 just to drill here in the Northeast for one house.
And that's not gonna cut it. It's gonna scare people off. It's gonna make it cost prohibitive.
It is, it is. The good thing about his model is that he's doing it at an economies of scale.
Right.
So he's saying, I can do 30 houses or 50 houses at once and share that cost with the homeowner for 20 years.
And when he shares it, is he building it into the price of the house?
So no, so what he's doing is he's charging a small monthly fee to each homeowner, and he's acting as a utility. Basically, instead of selling you gas, I'm going to be selling you geothermal energy.
Gotcha.
And he locks that in for 20 years.
So that's how he amortizes his cost and makes it sort of affordable for everybody.
For the life of the system.
That's actually a pretty good idea. Ideas that are being used elsewhere around the world?
Yeah, so it's great. District heating is what it's called in Europe. Proven model, right? So you got it in, Copenhagen, you have it in Munich,
Right.
Even in Reykjavik, Iceland. That area, that city is completely heated with a geothermal district heating system.
Like a municipal geothermal?
That's it. That's it. So he's basically taking that same idea and applying it to Austin, Texas.
That's pretty cool. The other thing that caught my eye was you had mentioned how the houses are fairly cookie cutter. And to me, that's music to my ears, because if they're regular houses and affordable, people are more likely to buy them. If they're super engineered and a crazy architect has designed this one-of-a-kind house, people aren't going to live in them.
There's nothing custom about these houses.
Right.
So these houses he's working with a production home builder.
Oh, really?
So what he's got is cookie cutter, off-the-shelf blueprints, and he's basically taking those and making them as best he possibly can by adding the spray foam, adding the geothermal, LED lighting, and just trying to get the operating costs as low as possible.
Well, which is awesome, which means if he can do it there.
He can do it anywhere.
Awesome.
That's right.
All right. Well, good story. Thanks for bringing it to us. Thanks for watching. This Old House has got a video for just about every home improvement project, so be sure to check out the others. And if you like what you see, click on the subscribe button to make sure that you get our newest videos right in your feed.